Hello, in this video brought to you by Sierra CAD/CAM, we are going to go over a standard setup for your mill turn machine. So to start, in most cases, when you bring in your part file, it will be located 90 degrees to the standard lathe view. The mill turn product makes that easy and one smooth step to just go ahead and orient that as needed. To start, we'll go to Machine, Mill Turn, and in this case, we'll go with this Morrissey NTX 1000. This particular machine has both a B-axis head and a lower turret for working on both the left and right spindle. The code expert will run to load the machine configuration. We can go ahead and minimize that and just leave it running in the background. It is immediately going to launch into the job setup page. This is where you can define your chuck, your spindle, and your jaws. If you happen to have work holding support or steady rest, those can be entered here. From the setup type, we're going to go ahead and go with the left spindle, and we're going to set the stock type to continuous bar stock pick pull cutoff. Now the options that you have available here, whether it be single pieces of stock or continuous and so on, is directly connected to what options are available in your part handling and pick off cutoff operations. From there, we'll go into our WCS, and this is where we're going to orient our part. So with the mill turn product, top is top based on the machine view. So we'll go to Align to Z, pick the nose of the part, tell it to transform to plane based on the top plane. And furthermore, we can adjust the orientation of the part by grabbing X, and we can control the alignment. Maybe I want it to align to this particular hole up top, or here, and so on. From there, we'll click OK. Automatically orients the part into lathe world for us, and we'll continue down the tree. Left spindle is where we're going to go ahead and start with part geometry. Pick our part and selection. Now it's automatically going to create the right spindle geometry for us, and we may also get this warning. So this warning is simply referring to the part size versus the chuck size. If you happen to encounter this error, we can go ahead and select OK, go back up into our work holding, and it's because our default chuck size is smaller than our part. So we'll go ahead and just make that 2.5, allowing it to hold our part accordingly. Now from here in our part geometry, we can continue down by creating the turn profile. This is going to create the necessary lathe geometry on the part for toolpath selection. From there, we'll go to our bar stock size. Notice it automatically pulled in the size of the part from the model. If we had a different amount of stock over, we can put that in, as well as front and back face stock. I'll go ahead and just add 10 thousandths to both of these. Continuing down the tree, we have our tool plane. And from there, basically the gist of this is, if we're on the left spindle, we want to be staring down the right face. So no changes here, and we'll step into our stick out. So the stick out is where we are going to clamp the geometry with the left spindle. I'll select our position here, and I can pick anywhere in space that looks close. And I'll go ahead and enter this and do kind of a whole value just so it's easier to keep track. It looks like I need to go ahead and make this chuck size a little larger, prevent that pop-up from coming up again. So right back up into our work holding, default, and instead of the 2.5, I'll just say 2.6. See if that solves it for us. Continuing right down, stick out, make that our 5.5 again. All right, there we go. No longer a warning on the chuck jaws. Step into our right spindle, and again, tool plane. On the right spindle, we're staring down the left face. Lastly, we just need to go ahead and assign a pickoff number. And from there, we'll use the bullet point again, and we'll say somewhere in this area, and we'll go ahead and round that off again, 4.4. Lastly, we have our cutoff tool width, and the cutoff tool width is important because that is what is going to be used in our pick-off cutoff operation. And currently it's stated from cutoff operation. If you happen to have a custom tool or a specific tool, you can select it here. For our purposes, we'll just put in the default size, 0.125, for our cutoff width. And I'll go ahead and green check. To help us in programming our machine, the system automatically creates view sheets relative to the left, right, or both faces, so we can quickly jump from one to the next during our programming. I'll go ahead and just apply some simple lathe tool paths to start with, and I'm going to start with a face operation. Now from here, for our facing pass, I'm going to use the upper B-axis head, so that's going to be defined as our upper left. And the tools are all located in tool change position. So I'm going to grab that tool, and then I need to go ahead and set the tool angle to 90 degrees so that it's pointing down in relation to the tool change position. From there, I'll go ahead and click OK, and I get my facing path. Now, because this particular machine has a lower turret, I'm going to tell the system to rough from the lower side. So I'll go to a roughing pass. Go ahead and chain this down here. Now, as soon as I grab the chain across the bottom of the part, it's automatically going to orient to the lower left turret for me. Automatically chooses it. Now from there, I'll go ahead and just grab the, we'll go with this 55 degree left. Again, the lower turret is already pointing to cut position, so there's no tool angle needed here. Rough parameters, I'll simply enable the stock recognition. Click OK. Now, while that is roughing, we can have our upper B-axis head in tool change and grabbing the tool for our finish. So we'll go ahead and apply that across the top chain. And we'll go ahead and grab the 35 degree, and we'll go ahead and adjust our tool angle down again. Finish parameters, really no change for our purposes, and we'll go ahead and click OK. Right, so now that we've got our three standard operations, we're going to go ahead and transfer the part to the right spindle. We'll go right up top to our pick-off, pull, cut-off. And all of these are very automated in the sense that you do have the option to change all of these values, but really I typically only change a couple, and one of which is my tool pre-position. I like to give it a little bit more distance away from X. And then I'll go down to my cutoff and verify that the operation or tool being used matches my settings. From there, everything else is pulled in directly from my machine group, and I could just click OK. And just that quick, it's run over and transferred my stock to the right side. Now I can go ahead and utilize the same tool paths for machining on the right side. So again, I'll start with going with a face. And I can utilize the same tool. However, instead of telling the tool angle to come down 90, I'll tell the spindle to also flip that tool 180. So 90, 180, utilizing the same tool in the opposite spindle, and I'll click OK. Continuing right along, I'll finish up, or rather continue on with a rough across the bottom. Again, because I picked the bottom, it shows the lower right. And in this case, I'll go with the left rougher here, 55 degree. Parameters, utilize my stock for the definition. And continuing right along, we'll go into our finish pass across the top, utilizing our same tool, and we'll implement the same angle, 90, 180 to reverse it. All right, now we're all finished there. And if at any time you ever had any questions, for example, when I did this face, I don't know if I picked the correct turret. And as you look, it is actually in the upper left. So I can simply go in, change it to my upper right, click OK, and now I'll regenerate the subsequent operations, and we're ready to go. So at this time, we'll go ahead and select all the operations and run them through our sync manager by selecting G1. Now that our sync manager is loaded, it displays both upper and lower streams in this case, again, because the machine has a lower turret. From there, what we want to make sure is that the operations are in sync. So for example, this lathe face can't go straight to the lathe finish. So we want to tell this rough not to approach until after the finish operation. Continuing on, we don't want this finish to approach until after the rough. All right, now from there, we can do the same for the bottom operations. With this rough here, continue on down. Let's go ahead and give this some more room. We have our right face, so we don't want this to approach until the end of our right face. And just as we did before, we do not want our finish to approach until the end of the rough. Now that we've got these sync commands in, we'll go ahead and select save, because you notice we have a yellow ball here. Whenever there's a yellow caution, that means that you've made changes to the file and you cannot launch until you've updated the system by saving it. Now that we have a green go, we'll go ahead and launch all of these items. And we do have the machine housing that typically pulls up out of the gate. We'll disable that, and we could quickly see our part. From there, we'll go ahead and let it run. And then clearly you can see we have an issue here because our turret didn't stay parked to the left. So to quickly fix that, close out of here, right back up to our turret park, and we'll simply tell it we do not want this to go home until the end of our upper spindle move is done. So do not go home until the end. And when we do that, notice now our syncs are out of order. So I can do a right click, renumber all sync points, save, relaunch. Running this through again. All right, now that we have our completed file, looks all good in our simulation. We'll close out of the verify, and from there, to actually get our code, we will select G1 to post. And now from there, you can see that we have our upper and lower streams, as well as our sync points. And those now can be utilized based on our first sync, next sync, last sync. And we could also come over here and say align syncs. Now with the syncs in alignment, you can see based on the weight code of the upper to the lower, clearly through the code side by side. All right, and that's all there is to it. That was a simple setup for our mill turn product.
Thank you. And if you have any questions, please give us a call at 530-268-8508 or send us an email to support@sierracadcam.com. Thank you.